Anyway, let's get started. It's a rate of reaction question. They want you to describe and explain. So there are two parts to it. Make sure you are aware of that. You need to talk about collision theory, how the rate change when concentration of the acid is increased. Alright, concentration, the unit of concentration is mole per dm cube, or you can think about mole dm minus 3. What does per dm cube means? Mole in 1 dm cube of water. Because it's an aqueous solution, right? Aqueous means you dissolve in water, so it's a mixture. Aqueous is always a mixture, yeah? So as concentration of H2SO4 increase, so we're going to state the obvious. We're going to use this definition by stating the obvious. There are more H2SO4 molecules in 1 dm cube of the solution. Okay, therefore there are more reacting H2SO4 molecules, can collide more frequently with zinc. Because it increases collision frequency, therefore the rate of reaction will increase. So concentration and also pressure for gases is to do with your density, you know, like, well, the molar density, I guess, how many mole in 1 dm cube. And then we talk about the obvious thing, we talk about reactivity in terms of collision frequency and how would that affect the rate. Yeah. Next page is about when temperature is decreased. All right, so it's not necessarily always increased. Here is increased, here is decreased. All right, so with temperature there are two things actually. So you have learned that temperature is a measure of kinetic energy, and kinetic energy is half mv squared. So when you lower temperature, your reacting particles actually slows down. Yeah, okay. When temperature decreases, when temperature decreases, the reacting particles, so we are not just talking about the acid, we are talking about the zinc solid particles as well. So both the reacting particles will slow down, meaning to say they will move slower. Okay, therefore will collide less frequently. That is to do with collision frequency. But the key thing about temperature is there is a second additional very important information. Okay, also as temperature decrease, we are talking about the proportion of reacting particles. So this second information only applies to temperature, whereas pressure, concentration, they only affect collision frequency. Yeah, okay. So also the proportion of reacting particles, oh, my handwriting is terrible, with enough energy. We can talk about enough or sufficient energy greater than or equal to the activation energy of the reaction will increase. So meaning to say, decrease, because we are decreasing temperature. All right. So the proportion of reacting particles with enough energy will decrease. If you don't have a lot of molecules that have enough energy to react, then your proportion of something we call effective or successful, whichever word you like to use, okay, collision will decrease. Therefore, rate decreases. You gotta mention the rate as well, because they did mention describe and explain, all right, how the rate would change. All right, zinc plus sulfuric acid is exothermic, so we know from there, if I start from there, zinc plus sulfuric acid, all right, then I know it will go through a hump, and the level of the energy level of the product will be lower than the reactant, because exothermic reaction means from the start, so that this is the level, this energy level from the start to the end, single-headed. Okay, you don't draw double-headed like that and like that. No, enthalpy change is always from the start to the end. Okay, it goes downward because the system, which is the reactant, it lost the energy. It released energy to the surrounding in the form of heat. That's why your product have lower energy. Your product is zinc sulfate plus H2. And there's the balance equation that's given there. I just happen to know that I can balance it very easily without looking on top there, okay? What else? To show the enthalpy change. All right, I already shown it. I label it. What else? So I know there's less than 0. Usually, some question will ask you to label activation energy, but here you don't have to because they don't ask you to. But activation energy will be from the start to the top of the peak. All right. Okay, next bit, rate of reaction. So you want to know. They tell you that you can measure the decrease in mass because this mass will decrease. So the mass of solid will decrease as it reacts. One other method, follow the progress of reaction. So this is for 2 marks. You should describe it. You are producing a gas, so forming a gas. So you want to know about the rate of reaction. Okay, so to find out rate of reaction, you can do change in volume of gas over change in time. So that's going to be equal to rate as well, because you're going to monitor the change in the volume of gas over change in time. So you can measure the volume of gas, which is CO2, form with a gas syringe. So this is your experimental skill and experimental technique. So you know what a gas syringe is? It's just like a collection of gas. So you're collecting the gas that is graduated in that container. So you know the volume that's formed exactly. And then you have to do this measurement at regular time intervals, so that you're doing an experiment, and then you can get volume of gas against time, maybe in minutes or in seconds, like every 10 seconds or something like that, cm cube or dm cube really. And then you're gonna have no gas at first, and then you're gonna have increase like this or increase like this or whatever, but you need to measure it at a certain time interval, is essentially. Okay, describe and explain using collisions between particles. So this is collision theory. They are talking about smaller pieces here, so it's to do with surface area. So red is faster. Red is faster with the smaller pieces of the solid calcium carbonate, and this is because the smaller pieces of calcium carbonate have a greater surface area. This surface area refers to the area in contact with the surface area in contact with the acid, in contact with HCl particles. And because you have greater surface area for you to have contact with HCl particles, you can collide more frequently, I suppose, can collide more frequently with the HCl. Therefore, red is faster. So it's to do with collision frequency here. Here in part C, they want you to describe and explain using collision theory when temperature is increased, but everything else stays the same. So we know that temperature is related to kinetic energy of the particles. So as temperature increases, the reacting particles gain kinetic energy. Therefore, they move faster, colliding more frequently. But temperature does not just affect collision frequency. Temperature also affects the proportion of effective collisions, which are slightly different from collision frequency. In addition, So that first bit does increase the rate of reaction as already, but in addition, temperature has a second effect. Increase in temperature also increases the proportion or the percentage of particles, reacting particles with energy greater than or equal to the activation energy, meaning to say you will get more effective collision. Therefore, more effective collisions and rate would therefore increase. So you get a faster reaction. So when rate increase, you get a faster reaction. What else? So here they outline the graph already. How does the concentration change? So it's a reactant, I told you. It's a reactant. As time progresses, you take it out every hour. As time progresses, the concentration will go down. No issue there. Deduce the concentration 4 hours from the start. So there's a t equal to 4 hours. So this is 4 hours. So if I look all the way up here, so it should be there. So it's there. So the concentration, if you read the graph carefully, this is 1.30. So this is 1.32, 34, 36, 1.38. The unit is already given, so you're lucky then, okay? At which point is the rate fastest? This is a change in volume of the reactant divided by time. That is equal to rate. Because here you're given, sorry, not the volume, the concentration. Concentration of the HCl reactant. The change in concentration of the reactant over time is going to give you the rate. We are looking at the gradient. Remember, y2 minus y1, x2 minus x1, that kind of thing. Yeah? Alright, so you need to say at which point, and you need to give a reason. So it's not just stating, it's state and explain. When you think about it, the steepest part of the reaction is going to be here, because when you compare, I don't know, if I just randomly draw another line like that, if I just draw another line like that, if I just draw another line, nope, like that. If you compare these 4 lines, 1, 2, 3, 4, okay, the rate of reaction is the fastest because it's the steepest. You see, it's the steepest. There is a biggest change, the biggest change in the volume, concentration over time. Okay, it's to do with the gradient. So it's to do with A. So I beg your pardon, they wanted at the specific point, right? So you really should draw a tangent at B, such as this. C is there, and then D is very obvious. It's not steep at all. Okay, it must be A. So A is where the rate of reaction is fastest, because a tangent drawn at A give the steepest gradient, and we know that gradient here, the gradient here is going to be the change in concentration of the HCl divided by change in time is equal to rate. So if you have the steepest gradient, that means your gradient value is the largest. Okay, next bit. Describe, explain collision theory. So this is collision theory. How does rate change when temperature is decreased? So all other conditions stay the same, so you shouldn't be talking about any other thing except temperature. So before you do anything, you should know that temperature is a measure of kinetic energy of a particle. Is directly proportional to it. So what happens is, as temperature decreases, So T here is the abbreviation of temperature. As temperature decrease, then average kinetic energy of particles also decreases. So all your particles will have lesser energy, and because of that, so these particles will therefore move slower, okay, and then they collide less frequently. So that is to do with collision frequency, because they just move slower, therefore they collide less frequently. But the most important thing also is that also the proportion of particles with energy greater than or equal to the activation energy is now lower. So we get lower proportion or percentage of successful collision. Okay, you use those terms, right? Or you will use the word, I'm sure some teachers or some school will use the word effective. They are essentially the same thing, successful effective collisions. Therefore, rate of reaction will decrease. Overall, slower reaction. I have described the reaction will get slower or decrease in the right reaction towards the end, but I still explain everything and then I state it. It's the same as stating and then explain. I mean, as long as you got all the points, really. Okay, so there was just collision theory there, but we also talk about the proportion of successful or effective collision as temperature changes. Next bit, quite straightforward. How does universal indicator change when you have acidic condition? So the indicator will turn red. So you should know that this is not a litmus, but when you have litmus, when you have an acid, you will have blue litmus turns red with acid. So the easy way to remember really is, even though this is not litmus, this indicator is still going to turn red, just like blue litmus will turn red when you have acid. Okay, name a metal. So you need a metal chloride insoluble in water. So all chlorides are soluble in water apart from silver chloride and also lead 2 chloride. So lead 2 chloride means is lead 2 plus and Cl minus. Oxidation state, yeah, Pb2 plus Cl minus. So you have 2 Cl minus there to balance out the things. So they want a name, so you have to write down the name. So silver chloride, or you can write down lead 2 chloride, but not formula, because this is formula, this is name. So be very careful. And I think this is a repeated, this is kind of like the same concept as where is it? Oh, it's not here really. I thought I saw it earlier. Oh yeah, here it is, right? All chloride is soluble except silver chloride and lead 2 chloride. So they seem to have tested similar kind of thing in the same paper, yeah? So just look out for it.